Hi, my name is Theron, and I will be discussing our topic this week on the impact of dams on fisheries resources. This week's topic relates to Learning Objectives 1, Apply Ecological Concepts and Principles to Problems in Fisheries Management, as well as Learning Objective 3, Assess the habitat requirements of both common and threatened and endangered fisheries resources. There are many differing opinions on how dams affect fisheries, and there is equally competing research that goes along with these opinions. However, for this week, I chose to review an article by Joanna Lechard and Daniel Hayes titled Effects of Elevated Water Temperature on Fish and Macroinvertebrate Communities Below Small Dams, which details the effects of warm water overflow from the dams and how it changes the population dynamics between fish and large invertebrates. The article begins by listing the benefits that are given to human society by the creation of dams, and these benefits also seem to do well for nature too. The production of hydroelectric power, flood control, and water level regulation are benefits that would allow for less abuse of natural resources. However, to the same effect, dams create blockages of water passageways that have the ability to impede migratory routes of fish species. Species such as salmon require migratory routes in order to spawn. Blocking these routes over long periods of time could potentially impact the population in an adverse manner. Even though the main focus of this article was how the creation of dams impacts the fish and macroinvertebrate communities by warm water runoff, it highlighted many side effects that have the ability to affect population that are often glossed over. The creation of dams has the ability to form sediment sinks where fine sediments get trapped in the lower layers of dam water. According to the authors, the creation of an impoundment can alter a number of physical and chemical factors such as stream substrate, dissolved oxygen, and water temperature. Water temperature is the main problem being examined here. The study stated that the bioenergetics theory believes that fish and macroinvertebrate feeding and metabolism are directly related to water temperature, and that as temperature rises, so does the organism metabolism, requiring them to feed more to sustain their systems. Research also indicates that cold water species have a threshold for how much temperature increase they can handle before the stress reaches a zone where they can no longer prosper. Here both Lessard and Hayes hypothesized that the syntheses of the chosen research organisms, brown trout, brook trout, mottled sculpin, slimy sculpin, and assorted macroinvertebrates would be lower in areas where temperatures downstream from dams were higher than average. Overall, the study was performed all over Michigan in a variety of lakes and streams and concluded that there is a possibility that warm water runoff from dams has the ability to affect the population of select cold water species that reside downstream from the dam. The research is still ongoing because of the fact that Michigan experiences drastic temperature shifts throughout the year, which changes the temperature of the waters downstream from the dams throughout the year. In the summer and spring, when the temperatures are higher than usual, this is an issue. But in winter and fall, when the temperatures are cooler, it might give the communities a chance to balance out. From this article, I learned that there are many difficulties that an area faces when a dam is set into place, but also that these damages are not always as clear and present like some researchers would like you to believe. Yes, it is an issue that populations of the selected species are impacted in such a manner below the streams, but there is a chance that these populations could